Hi everyone, today we are going to start 6.4, which is prove triangles are similar by side, 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 and side, angle, side. Side, side, side similarity theorem. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. All this is saying is that if we have the same scale factor on each sides of the two triangles, we then know that they are similar. So if the ratios are all the same, we can prove that the triangles are similar by side, side, side. So let's try this all together. So use the side, side, side similarity theorem. Is either triangle DEF or triangle GHJ similar to triangle ABC? So here's ABC. ABC. And what's nice is that we already know which sides correspond because of the color. So for example, 8 is going to correspond with this side 6 and this side 8. 12 is going to correspond with 9 and 10. And then 16 is going to correspond with 12 and 16. So we need to figure out which two are similar. So let's start with looking at triangle DEF. All right, so we're going to first start by looking at those two sides. So 8 over 6, and we can simplify that to 4/3. So our ratio right now is 4/3. Let's check out our next side, 16 and 12. So 16 divided by 12. And if we simplify this, we also get 4/3. Let's try this one more time because so far it's looking good. So we have 12 and 9. So 12 divided by 9. And that equals 4/3. So because all of my ratios simplify to 4/3, that means that all the sides are corresponding. So these two triangles are similar by side, side, side. But let's look at this last triangle and see why it is not similar to triangle ABC. All right, so once again, let's look at the corresponding sides. So 8 is going to correspond with this 8. So 8 divided by 8 is equal to 1. So let's look at this 12 and this 10. Well, right away we can see that those are not the same number. 12 divided by 10, that simplifies to 6/5, which these are not the same. So that means that those two triangles are not similar. And I can actually stop here. I don't need to move on because I've already proven that those fractions are not congruent. Find the value of x that makes triangle ABC similar to triangle DEF. All right, so first I need to figure out two corresponding sides that I know of, and we know 4 and 12. So I'm going to make those into a ratio. So 4 divided by 12. All right, next I'm going to use one of the equations that involves x. I'll use this one. And what side of the larger triangle corresponds there? It would be 18. So since 4 is in my numerator and it's part of this triangle here, I need to make sure I put x minus 1 in the numerator for my second equation, and then 18 in the denominator because that corresponds with 12. Now I'm going to solve for x here, so we are going to cross multiply. So 18 times 4 is 72 is equal to, now we have to be careful here because I'm multiplying 12 by this entire equation. So I'm going to do 12 in parentheses x minus 1. I would suggest that you guys write it out like this. That way you don't make the mistake of forgetting to distribute that 12 inside the parentheses. So if I simplify this, 72 is equal to 12x minus 12. Add 12 to each side, plus 12. These cancel. I get 84. is equal to 12x. Divide by 12. Divide by 12. And I get that 7 is equal to x. Which of the three triangles are similar? And then write the similarity statement. Now, looking at all three of these triangles, they're kind of they're in different positions. So what I want to focus on is the smallest number. So if I look at the smallest number out of all the numbers in the triangle, so for this one, it's 20. For the second triangle, it is 24. And for the third triangle, it is 30. So once again, I'm just looking at the shortest side of each triangle because those should correspond with each other. All right, so let's focus on these two triangles. So the first one and the second one. Let's see if the ratios match up, meaning that they have the same scale factor. If they do, they would be similar. So I'm going to do 20 divided by 24. And that simplifies to 5/6. Okay, so now let's look at the second largest side, which in this case would be 24. In this case would be 30. Let's see if those are the same scale factor. So I have 24 divided by 30, which simplifies to 4/5. All right, so I can stop here. Right away, I know that these two triangles are not congruent because one of my ratios is 5/6, the other one is 4/5. They're not the same, so these two triangles are not similar. All right, so next let's look at these two triangles. And we're going to start by comparing the two shortest sides. So if I write this out, I end up getting 20/30, and that simplifies to 2/3. All right, let's look at our next side lengths, which are the medium side lengths, and I end up getting 24/36. And this simplifies to 2/3. All right, so far so good. I still need to check that third side though to make sure all the sides have the same scale factor. So finally, I'm going to divide these two together. So I have 26 divided by 39. And when you plug this in your calculator, you do get 2/3. So these are all the same, meaning that those two triangles are similar. Now it did ask to write a similarity statement. So remember, our sides have to correspond with each other. So I'm actually going to redraw these triangles because we can kind of see that they're not in the same position. That way it's a little bit easier for us to write out the similarity statement. So here is my two triangles, and I redrew them. So the shortest sides are on the bottom. My longest side is on the right-hand side, and the medium side is on the left-hand side. And then I just matched up the letters, with what it told me up here. So here are my two triangles now. So I can say triangle MNL is similar to triangle ZXY. And I'm done. Side angle side similarity theorem. If an angle of one triangle is congruent to an angle of the second triangle, and the lengths of the sides, including the angles, are proportional, then the triangles are similar. So in our example here, if we know these angles are congruent, we know that this side, I'll just star it, and this side have the same, or their ratio is the same as these two sides, then we know that the two triangles are similar. Use the side angle side similarity theorem. You are building a lean-to shelter start from the tree branch, as shown. You can construct a right end so that it is similar to the left end using an angle measure and side lengths shown. All right, so we want to see, are these two triangles similar? Well, the first thing we see is that this included angle are the same. They're 53 degrees, okay? So now I need to compare this side to this side and see what my ratio is. So we'll start with the short side, which is 10. Divide that by 15, and we end up getting 2/3. All right, next let's look at the other two sides. So I have a side of 6 and a side of 9. I need to find that ratio. So 6/9. This simplifies to 2/3. So these are the same. So yes, these two triangles are similar. So yes, triangle GFH is similar to triangle BAC by side angle side. So we can, it asked us, can we construct a right end? So yes, we can. So we can construct a right end. And that's just saying, can you create this line and this line? Triangle similarity postulate and theorems. So here are now the three ways that we can prove that triangles are similar. The angle-angle similarity postulate, side-side-side similarity theorem, and the side-angle-side similarity theorem. So let's determine which two of the three triangles are similar and then find the scale factor for each pair. All right, so let's start with number 3 here. So if we look at the first two triangles, I notice that I have an angle of 38 degrees and an angle of 59 degrees. Those aren't the same. So that means that, I mean, they still could be similar. I don't know the other angle measures. So I need to kind of focus on the sides and see, are the sides proportional at all? So let's start with the shortest sides of each, which is 5 and 4. So 5. So 5 divided by 4, which is equal to 1.25. All right, so let's look at another side length. So we can focus on 7 and 6. So 7 divided by 6. And that is equal to 1.17. So these two proportions are not the same. They don't simplify to the same number. So right away I know that these two are not similar. All right, next let's check the second triangle and the third triangle. So I don't know any angle measures in this triangle, but that's okay. We can still look at the sides and see if they're proportional to each other. So the shortest sides here, we're going to start with 4 and 2. So 4/2. Sorry, this is really hard to write on. 4/2 is equal to 2. Okay, next let's look at the medium size side lengths. So that's 6/3, which is equal to 2. So far so good, but we do need to check that third side just to make sure. And so 7 divided by 3.5 is equal to 2. All these are the same, which means my scale factor is 2, or, well, if it's 2 if we're going from the small triangle to the large triangle, our scale factor is equal to 2. But remember, if we're going from the large triangle to the small triangle, my scale factor would be 1/2. All right, let's look at number 4 here. So let's look at the different side lengths here. We'll start with the short side length of the first two triangles. So I'll kind of highlight these. So 24 and 18. So let's do 24 divided by 18. And that simplifies to 4/3. Next, let's look at, we'll do 16 and 12. So 16 divided by 12. And that is also equal to 4/3. So far, so good. Now let's look at 20 over 16. And when we simplify this, we end up getting 5/4. So these triangles then are not similar. So even though these ones work out, this one here messes it all up. So I know that the first and second triangle are not similar. All right, so next let's look at the first triangle here and the third triangle. And these are going to be similar. So if you just look at the side lengths, you'll get the same scale factor. So I'll do this one pretty fast. So 24 over 30, we get 4 over 5. If I look at 16 over 20, we get 4 over 5. And then finally, if we do 20 over 25, we get 4 over 5. So these all work. So those two triangles are similar by side, side, side. Here are the last two problems that we're going to do together. So we want to verify that triangle RST is similar to triangle XYZ. Find the scale factor of the two triangles. Okay, so looking at these, we do know we have an angle measure that is congruent, 90 degrees. So I just need to look at the two side lengths and determine are those proportional to each other. So 4 and 6 are the smallest sides, so those have to be corresponding to each other. So 4 over 6, which if you simplify that, that is 2/3. All right, next we got to look at 6 and 9. So 6 divided by 9, if you plug that in your calculator, you will get 2/3. So yes, these are similar by side, angle, side. And the last one here, okay, so we are looking at, oh, in the scale factor is 2/3. I forgot to mention that. All right, so for number 6, I have that these two angles are congruent. So now let's look at the sides. So I'll start with the shorter sides again. So 21 and 12. So 21 divided by 12. That is 7 over 4. All right, next let's look at 28 and 16. So 28 over 16. And once again, that's 7 over 4. So 7 over 4 is my scale factor. So yes, these are similar because of side, angle, side.